Hello, grade 9 students. Let us recall the 6 trigonometric ratios. These are the sine, cosine, tangent, cosecant, secant, and cotangent. So let's consider a right triangle with theta as one of its acute angles. The trigonometric ratios are defined as follows. So figure 1, we have here figure 1 below. So recalling the mnemonic, which is what we call the SOHCAHTOA. Sine theta is equal to opposite side over hypotenuse. Cosine theta is adjacent side over hypotenuse. Tangent theta is opposite over adjacent. Cosecant theta, the reciprocal of sine, is hypotenuse over opposite. Secant theta is the reciprocal of cosine, so hypotenuse over adjacent side. Cotangent theta is the reciprocal of tangent, so adjacent over opposite. So the symbols we use for those ratios are abbreviations for their full names. Sine, cosine, tangent, cosecant, secant, cotangent. Now, since any two right triangles with angle theta are similar, these ratios are the same regardless of the size of the triangle. The trigonometric ratios depend only on the angle theta, which is what we call the reference angle. So for example, if we have here a right triangle, whose sides are 3, 4, 5, sine theta is opposite over hypotenuse, so 3 pips. SOHCAHTOA. So SOH, opposite over hypotenuse. Opposite of theta is 3. Hypotenuse is 5, so 3 pips the ratio. How about this? In this triangle, sides are 30, 40, 50. Sine theta is still opposite over hypotenuse, so 30 over 50, lowest term is 3 pips. Example 1, finding the trigonometric ratios. Find the 6 trigonometric ratios of the angle theta in figure 1. So the sides are 2, square root of 5, and 3. Opposite side is 2, adjacent side is square root of 5, hypotenuse is 3. So sine theta is opposite over hypotenuse, so 2/3. Cosine theta, adjacent side over hypotenuse, square root of 5 over 3. Tangent theta, opposite over adjacent sides, 2 over square root of 5. Or 2 square root of 5 over 5 if you rationalize. And of course, cosecant is the reciprocal of sine, 2/3, so 3 halves. Secant, reciprocal of cosine, square root of 5 over 3, so 3 over square root of 5. Cotangent, reciprocal of tangent, square root of 5 over 2. Certain right triangles have ratios that can be calculated easily from the Pythagorean theorem. Now, since they are used frequently, we mentioned them here. So the first triangle is obtained by drawing a diagonal in squares of side 1. So if we have here a square whose side is 1, all sides are equal, then draw a diagonal. Of course, this is 90 degrees, all angles are 90 degrees, so if you draw a diagonal, then it's 45, 45, 90. And then, since it's a right triangle, if you try to solve for the hypotenuse or the length of the diagonal, it's square root of 2. Okay, 1 squared plus 1 squared is 2. Square root of 2. So meaning to say, whatever the side or the length of the legs of an isosceles right triangle or a 45, 45, 90 triangle, just multiply it by square root of 2. So if this is 2, that is 2, the legs are 2, hypotenuse is 2, square root of 2. If the legs are 3, the hypotenuse measure is 3 square root of 2. So also we have here another triangle, an equilateral triangle. So by the Pythagorean theorem, this diagonal has length square root of 2. The resulting triangle has angles 45 degrees, 45 degrees, and 90 degrees. Now, to get the second triangle, we start with an equilateral triangle, ABC here in the figure 6. Equilateral triangle, all angles are equal, so 60, 60, 60, total of 180 degrees. And draw the perpendicular bisector DB of the base. Thus, if you try to bisect angle B, which is 60 degrees, so 30, still 60, and this is a right angle, so forming a right triangle whose angles are 90, 30, and 60 degrees. And the sides are 1, 2, and square root of 3. So meaning to say, if the hypotenuse is 2, and therefore the side opposite the 30 degree angle is 1/2 of 2, so 1. Or the side opposite of the angle 30 degrees, which is 1, if the length is 1, then therefore the side is, you just multiply it by 2. So if this is 2, this is 4, this is 5, this is 10. And the adjacent side, opposite side of angle 60 degrees, is just multiply the shorter leg by square root of 3. Right? So if this is 5, this is also 5 square root of 3. So that's why they're what we call special triangles. By the Pythagorean theorem, the length of DB is square root of 3. Since DB bisects angle ABC, we obtain a triangle with angles 30, 60, 90 triangle. We can now use the special triangles in figure 5 and 6 to calculate the trigonometric ratios for angles with measure 30 degrees, 45 degrees, and 60 degrees. Yan. So, if our angle is 30 degrees, sine 30 degrees is 1/2. Yan. Cosine 30 degrees is square root of 3 over 2. Tangent 30 degrees, square root of 3 over 3. Cosecant 30 degrees is 2. Secant 30 degrees is 2 square root of 3 over 3. Cotangent 30 degrees is square root of 3. Now, sine 45 degrees square root of 2 over 2. Cosine 45 degrees square root of 2 over 2. Tangent theta is 45 degrees, 1. Cosecant theta is 40 square root of 2. Secant theta is square root of 2. Cotangent theta, cotangent 45 degrees, 1. Okay, you can memorize this, or you can just draw the reference triangle, right, and apply the ratio of the six trigonometric ratios. Apply the six trigonometric ratios. So, and then sine 60 degrees square root of 3 over 2, cosine 60 degrees 1/2, tangent 60 degrees square root of 3, cosecant 60 degrees 2 square root of 3 over 3, secant 60 degrees 2, cotangent 60 degrees square root of 3 over 3. So you can memorize this part, or yes, you can memorize this table, or better yet, if you cannot memorize, you just recall the sides of those special triangles and then apply the ratio, the six trigonometric ratios of trigonometric functions of a right triangle. So to find the values of the trigonometric ratios for other angles, we use calculator. Mathematical methods, called numerical methods, used in finding the trigonometric ratios are programmed directly into scientific calculators. Calculators give the values of sine, cosine, and tangent. The other ratios can easily be calculated from this by using the following reciprocal relations. Okay, if you want to find the value of cosecant 50 degrees, all you have to do is divide 1 by sine 50 degrees. If you want to find the value of secant t, just divide 1 by cosine t. If you want to find the value of cotangent t, just divide 1 by tangent t. Okay, kasi reciprocal. They are reciprocals. We follow the convention that when we write sine t, we mean the sine of the angle whose radian measures t. For instance, sine 1 means the sine of the angle whose radian measures 1. Now, when using a calculator to find an approximate value for this number, set your calculator to radian mode. You will find that sine 1 is 0.841471. If you want to find the sine of the angle whose measures 1 degree, set your calculator to degree mode. You will find that sine 1 degree is 0.0174524. Okay, so they have different result depending on how you set your calculator. If it's angle, then set your calculator to degree mode. If it's radian, then set your calculator to radian mode. Now let's proceed to the short part, applications of trigonometry of right triangles. So we all know that a right triangle, or any triangle has 6 parts. There are 3 angles and there are 3 sides. So to solve the triangle means to determine all of its parts from the information known about the triangle. To determine the lengths of the 3 sides and the measures of the 3 angles. Okay, we have here triangle ABC. Angle A is 30 degrees and the hypotenuse is 12. Find side A, side B, and angle B. No need to find angle C because it's already solved. It's a right angle, 90 degrees. So how do we solve for side A and side B first? And how do we solve for angle B? So it's clear that angle B is 60 degrees. Where did we get that? The sum of the three angles of any triangle is 180 degrees. So if this is 90 degrees, this is 30 degrees, it's already 120 degrees. So 180 degrees minus 120 is 60 degrees. So angle B is 60 degrees. So this right triangle is a special triangle, which is a 30-60-93 triangle, right? So even if we do not use calculator anymore, we can be able to solve for side A and side B. How? Applying the rules for special right triangles. So which states that the side opposite 30 degree angle in right triangle is 1/2 the hypotenuse. So A is 6 and B is A times square root of 3 or 6 square root of 3. O, diba? So A is 6 and B is 6 square root of 3. Now if we are going to use sine function whose ratio is opposite over hypotenuse, A over 12. So sine 30 degrees is A over 12. And from that, if you cross multiply, we can obtain A by multiplying 12 by sine 30. Okay, 12 times sine 30 degrees is 1/2. 12 times 1/2 is 6. So 6. And if you want to solve for side B, we can use the cosine function because B and the other side involved is the hypotenuse. So adjacent side over hypotenuse is cosine. So we're going to use the cosine function. B over 12. So cosine 30 degrees is equal to B over 12. Again, cross multiplication. Multiply 12 by cosine 30 degrees. Cosine 30 is square root of 3 over 2. So the answer is 6 square root of 3. Diba? So how about this? Applications of trigonometry of right triangles. So to discuss the next example, we need some terminology. If an observer is looking at an object, then the line from the eye of the observer to the object is called the line of sight. So if you're looking at an object above you, then the angle formed is what we call the angle of elevation. Now if you're looking to an object which is located below, then the angle formed is what we call the angle of depression. If the object being observed is above the horizontal, then the angle between the line of sight and the horizontal is called the angle of elevation. If the object is below the horizontal, then the angle between the line of sight and the horizontal is called the angle of depression. If the line of sight follows a physical object such as an inclined plane or hillside, we use the term angle of inclination. Let's have here an example. Finding the height of a tree. A giant redwood tree casts a shadow of 532 feet long. Find the height of the tree if the angle of elevation of the sun is 25.7 degrees. Okay, here we have here a tree whose length of shadow is 532 feet, and the angle of elevation of the sun is 25.7 degrees. Find the height of the tree, the giant redwood tree. H here. So what are the sides involved? Sides involved are opposite side and adjacent side with respect to the angle of elevation 25.7 degrees. Adjacent side is 532 feet. Opposite side is H, which is unknown. So if these two sides are involved, then the trigonometric function we're going to use is tangent, because the ratio of tangent function is opposite side over adjacent side. So therefore, tangent 25.7 is equal to H over 532. And from this cross products, tangent 25.7 degrees times 532 is, okay, you can use your calculator now. H is equal to 256 approximately. So the height of the tree is about 256 feet. So that is how useful trigonometry is in finding the height of such tall objects. And that ends our short discussion on basic trigonometry. Goodbye and see you next time.